This is summer 2010 question paper 4-2, question 1b. Okay, my discussion will be focusing on finding the order of reaction with respect to each reactant, which is in part B2. Okay, now let's look at the data given. 3 experiments were conducted, okay, and concentration of phenyl chloride is changing from experiment to experiment. For concentration of sodium hydroxide, experiment 1 and 2, they are the same. Okay, experiment 3 is double the concentration of sodium hydroxide in experiment 1 and 2. So by looking at this, we know that we can use experiment 1 and 2 data to find the order of reaction with respect to phenyl chloride. So let's start. So I'll be using the reasoning method. So I'll write from experiment 1 to 2. Okay, I try to use short form here, but in the exam, you try to write as complete as possible because I'm trying to save space here. So as from experiment 1 to 2, so what happened to the concentration of phenyl chloride? Okay, concentration of phenyl chloride increased by 50%. Okay, or you can say increased by 1.5 times. So what happened to the rate of reaction? Okay, 0.03 divided by 0.02 is 1.5. Here 1.5 divided by 1.0 is also 1.5. Okay, also increased by 50%. So you see, the rate is proportional to the concentration. Right, so we can say that we can make a conclusion. Okay, order of reaction is with respect to phenyl chloride is 1. So first order reaction. Okay. Now, since we have found the order of reaction with respect to phenyl chloride, now I can use experiment 1 and 3, okay, or experiment 2 and 3, 1 and 3 or 2 and 3, to find the order of reaction with respect to sodium hydroxide. Now, why do I choose 1 and 3 or 2 and 3? Because concentration of sodium hydroxides are different in these two experiments. 1 and 3, see different, 0.1 and 0.2. Experiment 2 and 3 also different, right? Okay, so now let me show you how I do this. I'm going to show you the explanation method. Okay, later I'll also show you how to use calculation. So I'm going to use experiment 1 and 3, for example. Okay, let's look at experiment 1 to 3. Now, the concentration of phenyl chloride, okay, increased by how many times? Or how many percent? Okay, let me use a calculator to calculate this. 2 25%. And concentration of sodium hydroxide is increased by 100%, right? It's double. Okay, so order of reaction with respect to sodium hydroxide, okay, is also 1. Okay, now how do I know it is also 1? If concentration of phenosol chloride is increased by 35%, so this rate of reaction from experiment 1 to 3 should increase by 35%. Okay, let's see. So 1.0, right, increased by 25% will be 1.25. But we see here is 2.5, which is double 1.25. That means it is double again. Okay. So from 1.0 to 1.25, right, it is actually increased by 25%. From here to here, increased by 25%. And then from 1.25 to 2.5 is double. So the doubling in rate of reaction again is because the concentration of sodium hydroxide is double. So the rate is also proportional to the change in the concentration of sodium hydroxide. That's why the order of reaction with respect to sodium hydroxide is also 1. Okay, so this is how you solve this type of question. Now I'm going to show you what if, okay, you find this too complicated. Okay, you want to use calculation to prove that order of reaction with respect to sodium hydroxide is also 1. Okay, right, so I'm going to show you also how to use calculation. I'll put an or here so that you know that it is an alternative. So from experiment 1 and 3, so what I'm going to do is I'm going to use the rate equation for both experiment 1 and 3. So I'm going to use experiment 3 dy by experiment 1. Okay. So the rate equation for experiment 1 will be rate equals to K, concentration of phenosol chloride, to the power of 1, because order of reaction is 1. Then this one unknown, right? So I'm going to do the concentration of sodium hydroxide to the power of X, for example. So rate in experiment 1, I put rate 1, okay, equals to K, concentration of phenosol chloride, to the power of 1, because order of reaction with respect to phenosol chloride is 1. Concentration of sodium hydroxide, right, to the power of X, because I do not know the order of reaction with respect to sodium hydroxide. Then rate for experiment 3, okay, I'll put rate 3, equals to K also. Okay, phenyl chloride again to the power of 1, and sodium hydroxide also to the power of x. Okay, so now I'm going to substitute in the values. I'm going to divide this whole thing, okay, by this whole equation. So rate 1, okay, is 1.0. Rate 3 is 2.5. Sorry, experiment 3 divided by experiment 1, so it should be the other way around. So 2.5, right, divide by 1.0. Right, equals to K can be cancelled. Okay, we'll cancel it later. So in experiment 3, concentration of phenyl chloride is 0.025 to the power of 1. So I'm not going to write that one. Now I have concentration of sodium hydroxide 0.2 to the power of x. Okay, now let's put this. So then divide, right? Okay. K again. This time, experiment 1, 0.020 for concentration of phenyl chloride to the power of 1. Concentration of sodium hydroxide 0.1 to the power of x. Now you can see that this 2.5 divided by 1 is 2.5. Okay. Sorry about that. Okay. Okay, K can cancel out each other. Okay, 0.025 divided by 0.02 is 1.25. Okay, 0.2 power of x divided by 0.1 power of x. Okay, it will be 2 power of x. Okay, so 2.5 Okay, 2.5 divided by 1.25 is 2. 2 equals to 2 to the power of x. So from here we know x equals to 1. That is why the order of reaction with respect to sodium hydroxide is 1. So you make a conclusion. Okay, the same conclusion here. So the order of reaction with respect to sodium hydroxide is 1. Must always make a conclusion, yeah? So 2 methods. Now let's look at number 3 also. Then you have to write the overall rate equation for the reaction. We have found the order of reaction with respect to phenyl chloride and then with respect to sodium hydroxide. So you can write a rate equation here, which is quite straightforward. Rate equals to K, okay, concentration of phenyl chloride, okay, first order reaction, therefore is power 1, concentration of sodium hydroxide, okay, reaction is also first order with respect to sodium hydroxide. So another to the power of 1 again. So this is the rate equation. Alright. So describe the mechanism for this reaction that is consistent with your overall rate equation. Okay, you should show all intermediates and all transition states and partial charges. Now this one is back to your AS chemistry. Okay, you have a phenyl chloride, okay, which is actually a halogenal alkane. Okay, and then you have sodium hydroxide. So this is a nucleophilic substitution of a halogenal alkane. Okay. Now, because you have a reaction, okay, a first order reaction with respect to phenyl chloride, and then first order with respect to sodium hydroxide. So that means this is an Sn2 mechanism. So go back to your AS organic chemistry, okay, and draw an Sn2 mechanism for this part.